Hi, let's see the diode that we choose for our buck converter design. So as in the case of the MOSFET, we are going to talk about three rules we have to follow in order to choose this device. As in that case, these rules are personal and they were set considering this specific project and the scope of this project. Okay, so in any case, first rule is the breakdown voltage of the diode must be equal or higher than 1.5, the expected value in our buck converter design. So let's review the voltage across the diode, because this is something that we already explained in a previous video. So the voltage across the diode is this one. In state number 1, we have VI, in state number 2 is 0. So we know that the expected value is VI, the input voltage. In our particular design, the input voltage is 12 volts. 12 volts times 1.5 is 18 volts. So the rule, according to rule number 1, we have to choose a diode whose breakdown voltage must be equal or higher than 18 volts. The second rule is about the current through the diode, this one. And in particular is about the average current through that diode. So, second rule is maximum continuous forward current must be equal or higher than 1.5, the expected value, considering our circuit. As in the previous case, we already have a video talking about the current through the diode, is this one. And in that video, we already analyzed the average value of that waveform, was 1 minus D times the output current. In our case, D is 0.275 and the output current is 15.15 amps. So here we have 10.98 amps. 10.98 amps times 1.5 is equal to 16.48 amps. So in this way, we have to choose a diode whose maximum continuous forward current must be equal or higher than this quantity. Third rule is also about the current through the diode, but in this case we talk about instantaneous value. Again, we use the same current waveform. In that video we already talked about the maximum values of this waveform, and we obtained that is output current plus peak-to-peak current ripple through the inductor divided by 2. This value is 15.15 amps. This quantity is 3.03 amps, and everything is equal to 16.17 amps. The rule is maximum instantaneous forward current must be equal or higher than 1.5, the expected value. Okay, so we multiply this quantity with 1.5 and we get 25 amps. So we need a value equal or higher than this quantity. Well, now we are going to use, with these three rules, we can choose a specific diode for our design, and this is the design that I have. I have this specific reference. Okay, this is the name of the diode I have chosen. The manufacturer is ROM, which is very popular company, and this is important. This type of diode is a Schottky device. So why I choose a Schottky diode? I choose a Schottky diode because Schottky diodes in general they offer very low forward voltage drop when the device is on, and they are very fast in terms of switching. Okay, in general, turning off a diode could be a problem. Okay, it's not ideal. But if you use Schottky diodes, you will minimize that drawback. Okay, this is something that we will see in future videos when we simulate the circuit. But the good point is that Schottky diodes minimize the conduction losses because the forward voltage drop is small, and moreover they minimize that problem during the turn off of the device. The drawback of Schottky diodes is that in general they are only available for low voltage levels, but this is not a problem for us because we work with very low voltage at the input. We only have 12 volts at the input, so we can find a lot of Schottky devices. Well, so the breakdown voltage of this diode is 45 volts, much higher than the 18 volts requirement. Maximum continuous forward current 30 amps, much higher than 16 amps. Maximum instantaneous forward current is also very high, 100 amps. The forward voltage drop when the current is 30 amps is only 0.53 volts, and the size is also very small. You can check the datasheet and consider the dimensions in order to obtain this value. Finally, I want to explain how we use the diode model in LTspice. The good point is that in contrast to the MOSFET, in this case we have the model in the default installation of LTspice, so it's very easy. We only have to put the diode symbol, we have to choose or we have to click here in order to see the available devices on LTspice, and here in this list you have to choose the one that we want to use, this one. Okay, so it's very simple. So with this we finish with the diode selection, and in next videos we are going to talk about how we choose other components of our circuit. So see you